let's have some extra practice for the summative, shall we? So let's say we have a football that is kicked at 35 meters per second and 60 degrees to the horizontal. 35 is this velocity that is at an angle of 60 degrees right here. We need to find how far it will travel horizontally. In other words, we need to find x, and how high in the air the football will get, which is y. The first step that we need to make is to split the 35 meters per second into the two components, the horizontal and the vertical. In other words, how fast is it moving horizontally and how fast in the beginning, because that will change, the football is going vertically. In order to do that, we need to use trig. The x is the adjacent, so Vx we'll find as 35 times cosine of 60. Cosine of 60 is half, so therefore it's going to be 17.5 meters per second. The vertical component, this one right here, we can find through sine, so it will be 35 sine of 60 degrees, and that will give us 30.3 meters per second. Make sure that you keep them separately, because otherwise you might mix them up and it's not going to do us any good. Now that we have our vertical velocity, we can find the height to which the football is going to get by using the formula v final squared equals v start squared plus 2gy. We can use that because we know at the maximum height our vertical velocity is now 0. The projectile is not going to get any higher because gravity basically ate up the entire velocity. We can find y from this formula as 0 minus our v start squared over 2g. It's this equation right here, just rearranged. We say 0 minus, so we take this, put it to the left with a minus. This is 0. And then divide by 2g. That's how we get our y, the maximum height. So y would be 0 minus 30.3 squared over negative 19.6. All I did was just multiply negative 9.8 by 2. That's negative 19.6. And then there is no reason to terrorize your calculator. I can just rewrite this as 30.3 squared over 19.6. That gets us 46.8 meters. You can actually round it to 47. Now, in order for us to figure out x, we know that the formula that we can use is Vx equals x over t. We need to find the time. We can use the notion that at the top, our vertical velocity is 0, so I can say Vy is 0, and here's your reminder right there. If I know that at the top, vertical velocity is 0, and I know that that happens because of acceleration, I can grab this equation right here and find half time. So to find half time, again, do not use 35. Do not use 17.5. You can only use the vertical velocity, which was 30.3. Negative 9.8, which is acceleration, equals, the formula calls for Vf minus Vs, final minus starting. Final is 0 at the top. At halftime, 30.3 divided by t. When I'm looking for something in the denominator, I can just swap like this and get t equals, I can keep minuses or I can drop them. 30.3 divided by 9.8, 309. 309 seconds, which I can round to 3.1. If I were to measure the time that it takes to get to this half point, that would be 3.1 seconds. So then another 3.1 seconds takes the ball to fall down. So to get the full time, I just multiply 3.1 times 2, 6.2 seconds. I can use this time in the horizontal. That would be where I will plug in my time. To rearrange the formula, x will be Vx times full time. Vx, again, not 35, not 30.3, but 17.5. So 17.5 times our full time, which is 6.2 seconds. That gives me 108.5 meters. So you can say it's about 109 meters if you want. Or you can just keep 108.5. And that is it. These are the steps that you make when you're solving a problem about a projectile launched at an angle. First step, separate the speeds. Then you can figure out the maximum height right away. Then you find your half time. Then you double the time, and then you put it right here in the x equals Vx times time. Please, please, please Keep those velocities separate. Do not mix them up. This table will help you.